Like I say, you'll have to talk to a real radioactive or scientist about this kind of stuff. But things that are not affected by radiation are things like paper. They don't become radioactive. Realistically, only just metal, gold, any kind of metallic object will become radioactive. Um, but most other things don't actually become like I say, metal soaks up radiation like a sponge, like, and then it'll just give off radiation, and it becomes reactive. That's why the Chernobyl reactor was called a lead reactor. Lead is a very soft or very it's very easily lead reacts with a lot of things. Lead reacts with acid. Lead. Anyway, I don't know that much about science actually. I only know a basic thing. But basically, the reactor in Chernobyl was actually a lead reactor. What you do is you pick up all those little guys and you go. You take all those off, and then at the core, deep down inside, there's lead. Basically, I forget how the lead works. I forget if there's pellets or a big block or something like that. But basically, there's lead at the core of the Chernobyl reactor. It was lead. You put lead down there and it reacts. Basically, it creates heat and it gives off whatever. Anyway, you'd actually have to take it apart, but basically there's lead down there. Anyway, whatever. I don't really care. It was my reactor, it was my city a long time ago, and I spent a lot of money for it and sent my people to do it and work on it and build it. And we built it, and it worked for about 250 years. Chernobyl, like people say, oh, it was commissioned and then it blew up. No, 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 no. No, it was the foremost and best city for about 250 years. How long it actually was a city it has actually been covered up. You don't actually get that big of a city overnight. We built that big of a city, but that was that was an epic city, and it was actually a city for like I said, there was Olympics at Chernobyl. We had the Olympics that were lit by nuclear power. There was a lot of stuff that happened at Chernobyl, and even after the Olympics, the astronauts went and used the big deep pool at Chernobyl and other complex sites around Chernobyl. I mean, it was used for a very, very, very long time, even after the accident. Once we did the cleanup and it was mostly safe, astronauts, because when you go up into space, you're going to get irradiated anyway. Being up in space is comparable to being, working at a reactor. You're even with all the shielding, you're basically becoming radioactive. That's why you can only go so many times in space, because pretty much you're going to get radioactive no matter what. You're being exposed to radiation because there's lots of radiation up there, tons of radiation up there, so much radiation. Like I said, the air, I call it a hydro air shield around the Earth. The air actually protects us a lot, and plus other things like our magnetic field and all that other stuff. There's a lot of reasons why we're actually protected from those little rays that come. Like I say, next to the sun is really dangerous. You cannot go. Anybody who goes next to that sun, you basically die. And it's not the heat that kills you. It's actually all the particles. Anyway, whatever. It doesn't really matter. But basically, there's certain reasons why. I think there's actually another thing, like if you ever stop moving, like if you try and blast like that way, there's a reason why we never go that way. Anyway, because we're already moving this way, and if you get directly or stop directly in line with the sun, you'll pick up a lot of radiation all of a sudden. Moving at such speed around the sun is actually a good thing. For some reason, I forget what it is, but it helps. As the particles are going like this, you're not. The point is that because you're moving, you're not being directly hit by a particle. You're actually like encountering particles like this. So as long as you don't encounter particles from the side, because the particles are still moving really fast, so it's kind of like a glancing blow or something like that. I don't really know that much about it, but basically the particles are moving really, really fast from the sun, and being this distance away from the sun, the point is that by the time they've gotten to you, you're not where you were before. You're actually over here, and I forget why that helps, but it helps. Basically, it's why we stay alive. If you ever go that way against the particle stream, if you ever cancel your speed where the particles are coming directly at you, you die. Basically, I think there's a couple do's and don'ts with space. You don't ever want to go that way. Most people be like, Brian, shut up. You shut up. I actually took part in this, and there's certain do's and don'ts because we've thought about it. We've thought about going that way, into stuff. Like, why not go that way? Well, there's a reason. Basically, you encounter the particle stream, and when that happens, basically the Earth. Everyone thinks that the Earth is moving slowly around the sun. No, 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 no. We're zipping. We're moving really fast. We're going like something 100 trillion miles an hour. We're moving so fast that by the time the particles get out here to us, we've moved. So basically, what we're encountering is particles that we're getting glancing blow to particles. We're basically moving into the particle stream, and so it's less dangerous. Basically, is the point. Our speed is what actually keeps us alive. Is that if you like I say, if you ever stopped, if you took took the Earth and actually went and stopped it, right? Everything on the sun side would die. We'd all go from the radiation or from the particles. Basically, we'd be getting direct line radiation, and then we would die. So there's a reason that it's this, because a long time ago I actually took part of this shit. And like I say, certain people are like, blah, 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 blah. It's like, shut the fuck up. You don't know what you're talking about. Sorry. I get all mad at them because because they think they're so smart and they think they know what they're doing. But it's like, no, you don't. We've actually worked it out where we're actually moving really fast. And it's our speed of movement forward that actually keeps us alive. If we ever stopped, we'd die, basically. Like I said, I designed this damn thing. I took part in it. So anyway, though, basically the point is that we're moving this way enough that we're not getting direct particles. Don't ask me why it matters, but it matters. Basically, it does actually work. So anyway, and everyone says it's the magnetic shield. It's not the magnetic shield. It's partly the magnetic shield, but it's also the fact that we're moving so fast, which is why rockets never go that way. You never want to go against it, because when you're going that way, you get to that point where the particles are just coming right at you, and then you die, basically, pretty much. So there's do's and don'ts to space. So anyway, and most people don't really understand these things. Trust me, we found out. And it wasn't exactly good. So anyway, whatever. Find out yourself. It's just basic working knowledge of what keeps us alive.